I'm Vikas Mishra and I'm currently working in Nagaro Softwares, Gurgaon, and I'm here to present my MTech thesis paper, generating optimal query plan for distributed query processing using teacher learner based optimization. Here is the flow of my presentation. First I will give some introduction about distributed database, then distributed query processing. After that what is the objective, and then heuristics for the cost model, and then about TLBO, the teacher learner based optimization, then comparative analysis of experimental results with the existing techniques. In modern days, both application user and operational database are geometrically dispersed, and they are actually connected with the computer network, which requires more reliable data and highly available data. And database should be expanded in the future. The flexibility should be available. And in application domains, end users mainly concerned with the top 5 or top 10 or top K results of the query, and there are many advanced database systems also which are used in application domains like distributed database, heterogeneous, and data space etc. Distributed databases mainly consists of loosely coupled sites which are located at other locations, and data may be replicated over the sites or fragmented over the sites, and query may access data from any of the sites, more than one sites also, and each site will have some parser results which will be contributed to the final result. Then replication data may lead to a generation of multiple query execution plans for processing the query. Then distributed query processing provides the policy or optimal policy for processing the query. Then the main objective of distributed query processing is to minimize the data transmission cost between the sites. In distributed query processing is a cost-driven optimization. Distributed query processing is a cost-driven phenomenon where the cost can be communication cost, query localization cost, or query affinity cost, IO cost, etc. Then, and also in distributed query processing, query optimization is the main part and important part, because data is replicated to the various sites, so multiple equivalent query plans possible. In these group of query plans, we have to find optimal query plans so that give the best result. Here in the figure, if user is giving any query, then we will apply some transformation rules and create some search space or find the optimal query plan. Here in this search space, we will apply some cost model and apply some search strategy to find best query plan. In distributed query processing, if you are going to find the query execution plans which are optimal, then we have to use some cost model. On the basis of that, we will find the fitness value, you can say, or the overall cost for that execution plan. So till now there are so many techniques like genetic algorithm, multi-objective genetic algorithm, PSO, ACU. All these techniques are used for finding the query execution plans. So cost model will play a main role for finding these optimal plans. So our objective is to formulate the cost model for distributed query processing and perform some experimental analysis over existing optimization techniques and implement TLBO also. Here are the heuristics for cost model. First is query affinity cost. This cost will mainly concern with the number of sites which are going to be accessed by the query plan for giving the result. Second one is query localization cost. This cost will be mainly decide the control side for query processing and the degree of communication between the sides. How much data is going to be transferred between the sides, that will be the concern. And third one is local processing cost, which will concern with the selectivity of operators and on the local relations. Then distributed query processing, how we are defining our problem. Like if we are given a query where from clause having relations from like R1 to R8, and on the basis of the predicates in the where clause, we have to give the result for this query. Then this site relation matrix will show the distribution of relations over the site, like where the entry is 1, like relation R1 is present at site 1, and where is 0, that relation will not present at that site. Based on this relation site matrix, we will generate the query execution plan. In first population query plan, where you can see that there are 8 relations, and this query execution plan will have the length as the number of relations in the from clause, where the entry in the query execution plan like 1, 1, 2, 2, 3, 5, 3, it will be the site number where that relation is existing. So on the basis of this relation site matrix, huge number of query execution plans are possible. In these many query execution plans, we have to find optimal query plans like top 5 or top 10 or like that. Here here we are just comparing the TLBO with the other optimization techniques, why we are going for TLBO. In most evolutionary and swarm intelligence based algorithms, which are probabilistic and they require parameters to perform the optimization, and they have to tune some control parameters, which are common control parameters like search space size, number of generations, elite size, and additionally they have to also tune algorithm specific control parameters, which are like in GA crossover probability and that mutation also, and inertia weight and social parameters in PSO also. So the proper regulation, if we are not going to tune these parameters well, then cost value of the execution plan will increase automatically. So this is the problem. That's why we are going for TLBO, which is parameter less technique. The TLBO optimization technique was developed by R.V. Rao in 2010, which is widely used for decision making scenario on manufacturing process like civil engineering and electrical engineering. It is mainly based on the principle of teacher and learner knowledge sharing, where we can take our problem as learners as possible. There are so many learners, and we are taking as a population, like query execution plans all on the population. Okay, and the subjects we are offering to the learner, that will be the design objectives, and the results of the learners will be the optimal query plans. So TLBO algorithm is mainly based on 2 phases, teacher phase and learner phase. Initially the population will be, as I said, population will be the number of query plans, all the possible query plans for the query, and it will have pre-computer fitness value, which I have proposed, which I have given query execution query affinity cost, QLC and LPC. After that, based on these 3 pre-computed fitness values, we will find the overall fitness value for each execution plan. Which execution plan will have minimum cost or good fitness value, that will be elected as a teacher, and based on this teacher knowledge or this fitness value, we will find this teacher factor, which will update all the learners knowledge or learners fitness. After that, those learners will share their knowledge, or we can say fitness, to fitness for improvement of other poor learners, or you can say execution plan. Here you can understand, I will show the flow graph also, like that initial so in teacher phase only best query execution plan will be fetched from all the possible query plans, and its knowledge will be populated to the other query execution plans. Here is the example, as we have given a 20 query execution plans. For this, QAC, QLC and LPC are computed, then fitness value find for each query execution plan. Here query execution plan 15 is having less communication cost and less total cost. That's why it will update all the query execution plans knowledge, or you can say fitness value. After that, in learner phase, they will communicate to each other, or you can say compare the fitness value pair wise, and update their fitness values till predefined iterations. After that, finally the ranking of the query plan can be done on the basis of the final fitness value, like 15 will be the best, then 19, then 9, and then 13. Here are the experimental results. We have compared the TLBO algorithm with the pre-existing algorithm, GA based algorithm, vector evaluated genetic algorithm, and aggregation based GA algorithm. In Vega and aggregation based GA, PC and PM, the crossover probability and mutation probability, we have to fix it or tune it, but in TLBO we don't have to give any parameter. And we have plotted the graph between the number of generations required for the finding top K query plans. In the first graph, we can say the graph between number of generations and query cost, and we are finding top 5 query plans. Here TLBO is taking less number of generations as compared to the TLBO and Vega for performing the good results. In second, top 10 we are finding, and top 20. Secondly, we have plotted graph between number of generations and the top K query plans, where we are fixing query cost. Here also we can see that TLBO is taking less number of generations. After that, we are plotting the graph between number of generations and the population size. If we are increasing the population size, then we are finding top K query plans. In conclusion part, first we have discussed distributed database, then query processing, and then compare why we are using TLBO, and our contribution is to formulate the cost model for the query processing, and a parameterless optimization algorithm TLBO is employed to generate optimal top K query plans, and comparative study is also done. So from the results we can see TLBO is giving the best results.
Any queries from the audience? First thing is, in the slide preparation, we should consider that font size in some few slides. It's not visible properly for the last audience. And then you told something about the search strategy. What is the algorithm you will be using for that search strategy?
For searching?
Yeah.
I'm saying search strategy, that is we are using this optimization techniques only. We have population of query execution plans, and we are performing this optimization technique to find best query plan. That is the search strategy. Like we are using TLBO for searching.
TLBO itself is for searching? It's for learning process, right? And then teacher and then learner phase. Then how come it will work for that?
We have possible execution query plans, and then we are performing this optimization technique for finding best query plan out of them. That is.
Okay. Then you said something about that evolutionary computing and this on intelligent computing, the parameters, whatever the parameters, it's more than TLBO, right? Then how come, on what basis you will be selecting that the parameters for TLBO compared to that evolutionary or swarm intelligent? TLBO, it's also a machine learning, this one, right? The learners based and then knowledge based means it's also a machine learning only. Then how come the parameters will be setting for that?
For GA based technologies that I have compared with, that's Vega and that aggregation based technology, aggregation based optimization, where we are using mutation and crossover, that parameters are probability of crossover and permutation that we have to set. If we are setting them less or more, then the results will be different. But in TLBO we are not setting any parameter. We have just calculated the three cost parameters, that is QSC and QLC, but we are not setting any parameter. But for finding optimal query plans, we are using number of generations only. That how many number of generations it will take for getting the optimal.
Even in the TLBO also, for a teachers or the learner phase, there you need to set some weights, right? The knowledge base, since it's a knowledge based, you require some weights and then query cost and all those things.
No, we don't have to set weights. From set of query plans, which query plan is having minimum query cost, that is going to be the best plan. We are
That's what, on what basis you will be calculating the query cost?
What? Sorry?
Query cost.
Query cost.
How you will be setting that? How you will be finding that?
We are just squaring these three computation cost and adding them, which will be the least cost, that will be the least fitness value.
Initial query cost is asking, not at the end.
I have proposed three formulas for that, query fancy cost, query localization cost, with three heuristics which I have shown you.
Is that your complete, the proposal is from your say, or already it's an existing one?
These three heuristics I have formulated for finding the fitness of the query plan.
What will the total cost be?